Hi friends, welcome to my another video. This video is a second part for the variable frequency drive. In this video, we will discuss that how the variable frequency drive overcome all the problems which we discussed in the part 1. In the part 1 video of variable frequency drive, we discussed that in order to control the speed of the motor, either we have to control the parameter of the power supply, and there is a three parameter for the power supply, that is voltage, current and frequency. If we are able to control any of these, then we can control the speed of the motor. Or we discuss the second option, that we have to make any alteration in the motor itself in order to regulate the speed of the motor. In part 1 video, we discussed that when we try to change the supply voltage in order to regulate the speed of the motor, then we find that by changing the applied voltage on the motor, we are compromising with the torque. And we also find that by changing the large amount of the applied voltage, we are getting a very small change in the speed. So the range of controlling the speed of the motor is very limited in case of regulating the speed of the motor by changing the applied voltage. And the biggest drawback of this method to regulate the speed of the motor is that we are compromising with the torque. As we decrease the voltage, we are decreasing the torque of the motor. After voltage, we are trying to change the frequency in order to have control on the speed of the motor, which is very clear from this formula that when we will change the frequency, we can change the synchronous speed of the motor. But as we are going to change the frequency, we are getting some consequences. What is that consequences? Is that when we are going to increase the frequency of the power supply by keeping the voltage constant, then we are having a low flux in the stator core, and when we are reducing the frequency in order to regulate the speed of the induction motor, then we have enough flux which cause the saturation of the core. When increasing the frequency, then the flux goes down, which reducing the torque of the motor. And when we are decreasing the frequency in order to control the synchronous speed, then the flux goes high and it will cause the losses in the motor and make the core saturated. So because of these two consequences, it is not a good idea to control the speed of the motor by changing the frequency. Lastly, we discuss about the stator poles. As we seen from this formula that by changing the pole of the motor, we can have command on the synchronous speed of the motor. But when we are going to make more and more poles in the stator winding, then it will make the motor winding very complicated. And if we want to switch the motor winding from 8 pole to 2 pole or 8 pole to 4 pole, it will make the more complication in the stator winding of the motor, which will ultimately increase the cost of the motor. And by switching the poles of the motor from 8 to 4 or 8 to 2, we are getting a few range of the speed and we are not getting a wide range. Like a 6 pole motor have a RPM of 1000, then by switching it to 4 we will get 1500 RPM, but we will not get any speed between 1500 to 1000 RPM like 1200 RPM. We will not get such a speed. Or by changing the 6 pole motor to 2 pole motor, we will get the speed of 3000, but we will not get any speed in between them except 1500 if this 6 pole induction motor has a switching mechanism to change into 4 pole motor. So by increasing the complexity of the stator winding of the motor, what we are getting a very narrow result for the speed change of the induction motor. So this method is also not practicable. If you want to know these things in detail, then watch my video, link will be in the description. As we seen in the frequency changing method, that we can control the speed of the motor by changing the frequency of the power supply, but we are facing one problem, that by changing the frequency, we are changing the flux, which is not good. When we are increasing the frequency, we are decreasing the flux, which result to reduce in the torque. And when we are decreasing the frequency, then it increasing the flux, which lead to the saturation and increases the losses in the motor. So in this method, what is the problem is that the flux density is changing with the changing of frequency. So the solution of this problem is hidden in the problem itself. What we can do, we can keep the flux density of a stator core constant by changing the voltage and frequency together in same proportional, so that the flux generated in the stator core of the induction motor always constant. Previously, we see that when the voltage was constant and when we are increasing the frequency, it lead to decrease in the flux, and when we are decreasing the frequency, then it lead to increase in the flux. So what we will do, we will change the voltage also in a equal proportion, that the change in the frequency and change in the voltage together will always lead a constant flux. If we will achieve this one, then what our benefit, we are changing the frequency, so ultimately our speed of the motor will change, but the consequences of changing the frequency will also vanish, as we are changing the voltage in same proportional, that the flux density in the stator core always constant. So this method is called constant voltage frequency control method for the induction motor speed. This is the function of variable frequency drive, meaning the variable frequency drive not only changing the frequency but also changing the magnitude of the voltage. That is why this variable frequency drive is also called variable voltage variable frequency drive. It has other name also, like variable speed drive, adjustable speed drive, adjustable frequency drive, alter inverter, AC drive, or micro drive. There are different names, but it reflects to the same, that is variable frequency drive. So what we learned so far, that variable frequency drive changing the frequency but as well as changing the voltage in order to make the flux density always constant in the stator core, which was the consequences which we are facing when we are only changing the frequency of the power supply. So what is the function of variable frequency drive? Variable frequency drive regulating the speed of the motor by changing the frequency and voltage in order to keep the flux density in the stator core always constant. But might be a one question arise in your mind, that in constant voltage frequency ratio method, we avoided the consequences which arises due to only changing in the frequency, but due to that we are decreasing and increasing the voltage also. Meaning what we learn in the first step, that when we are regulating the voltage, we are compromising with the torque of the motor. So in this method also we will compromise with the torque of the motor, as in this method we are changing the voltage. So let us analyze this one. What is the situation? What is the impact of the voltage change also in constant voltage frequency ratio method? Here, this is the equation, okay, which we are discussing based on this equation. Suppose when we are only changing the voltage and other things are constant, then what is the impact on the torque? As per this equation, when other things are constant, we are not changing frequency, only changing the voltage, then the torque is directly proportional to the voltage, which I mentioned here. Torque is directly proportional to the voltage. Now in second method, we are not changing the voltage, we are changing only the frequency, and we are checking that what is the relation between frequency and torque. So everything is constant, so torque and frequency will be inversely proportional to each other. This frequency will come this side and other things are constant, so we can say that the torque is inversely proportional to the frequency. Now in voltage and frequency constant ratio method, we are changing the voltage as well as frequency. In first case, the voltage is 430 volt and the frequency is 60 Hz. So what is the voltage and frequency ratio? 430 by 60 Hz. It will be 7.16. Now, okay. In second method, we are changing the frequency to 53 Hz and changing the voltage to 380 volt. So again the voltage by frequency ratio is 380 by 53, that is same as 7.16 in both the cases. Okay. Now let us assume that in case 1, when the voltage is 430 volt and the frequency is 60 Hz, the torque of the motor is X. Let us assume in order to understand. Now we reduces that voltage. As we reduces the voltage, the torque is now no more X, it will be less than X. because torque is directly proportional to the voltage. As voltage decrease, the torque also decrease. But in this case, we are also decreasing the frequency. As we decrease the frequency, then what will happen? The torque will increase. It means torque again increase. So what we observe so far? In this voltage slash frequency constant ratio method, the torque of the motor is always not constant, I can say, but it is not compromising so much as we seen in the only changing in the voltage method. So what we can say here, that of course by reducing the voltage, the torque get reduced, but at the same time we are decreasing the frequency to have constant V by F ratio, and due to decreasing in the frequency, again the torque increase. So one side the torque is getting reduced due to decrease in the voltage, but another side due to decrease in the frequency, the torque get increased. So we will get almost same torque in this method, voltage frequency ratio method, constant voltage frequency ratio method. The method which we discuss here, that is constant voltage frequency ratio method for the speed control of the induction motor, is the working function of the variable frequency drive. And that is why the variable frequency drive is also called variable voltage variable frequency drive, as the variable frequency drive VFD not only changing the frequency but also changing the magnitude of the voltage. So in this video we cover the working function of the variable frequency drive. In our part 3 video, I will discuss about the different components, different part of the variable frequency drive, and how the variable frequency drive change the voltage and frequency. If I will discuss these things in this video, then the length of the video will go very long and no one will watch the long video. So stay tuned. I will upload the part 3rd video of variable frequency drive in upcoming 2 or 3 days, and we will summarize this variable frequency drive. If you find this video informative, then please give thumbs up and subscribe to my channel. We will meet in any other video. Till then, take care, keep learning, and bye bye. Thank you so much.